With the start of school, my son needed a homework desk. I wanted to build him a great one, so I included an extra feature.
I'm done with my homework.
For the desk sides, I chose 3/4-inch MDF. A few bits of oak here and there hold everything together. It's a rather straightforward desk with a slanted top. The top is made of MDF too and hinges up on a piano hinge to reveal a compartment for the mission control panel. I rounded the edges and sanded, then painted it all white, but used a magnetic primer on the inside of the lid so magnets will stick to it. To fill the hidden compartment, I made control panels out of 1/8-inch masonite, drilled holes in the corners, and glued templates I created in a CAD program onto the backs. I drilled a whole bunch of holes, cut out a whole bunch of slots. I primed the panels, sanded them, then painted them gray. I printed labels on inkjet transparencies and glued them to the panels, trimming the holes and edges. I populated all the panels with rocker switches, toggle switches, illuminated push-button switches, rotary and linear potentiometers, LEDs, bar graph LEDs, and 7-segment LEDs. I mounted the panels onto a frame of 1x2s, screwing them in with number 6 screws and finish washers for a technical look. I modified the illuminated push buttons to hold larger LEDs and made labels for them with inkjet transparencies. For my status indicator panels, I made LED holders out of aluminum. I cut dividers from plexiglass and notched the dividers with Dremel so they would slot together. Put reflective tape on the dividers and mounted them under a diffuser I made from a cutting board. An Arduino will read inputs and command LEDs, cooperating with a Raspberry Pi that will play sounds and handle gameplay. I used 5 LED matrix drivers to control all the LEDs, allowing control of up to 640 LEDs. I used 4 I/O expanders to register all the switch changes and button presses. There was a lot of soldering involved connecting everything together. It took a few spreadsheets to keep track of all the connections. The big panel of panels slips into the compartment of the desk. I found a self-adhesive world map just the right size for our mission control console. To reflect the position of the spacecraft in orbit, I hacked a fridge magnet into the shape of the CSM and LV. An iPad will serve as an extra data display and play a curated set of space-related videos. This Velcro-lined aluminum channel will hold it in place. It's playtime. I made a few checklists for my flight director to go through.
Fido.
Go.
Guidance.
Go.
Surgeon.
Go.
All stations go for lunch.
The sequence panel controls sound bites from NASA representing the major events throughout a mission.
We confirm ignition and the thrust is go.
Some panels are good for fiddling, like adjusting the variables on this EECOM panel, or testing the lamps on the status panels. The attitude and surgeon panels just give random numbers within certain ranges, since we don't yet have a spacecraft or astronaut to track. The panel marked control operates a few of the imaginary spacecraft's mechanicals. I programmed a secret trigger for a simulated lightning strike, as happened to Apollo 12. I programmed the same solution they used, switching SCE to aux. Overusing the rockets on a spacecraft can cause trouble, so I count button presses and trigger appropriate alarms. I expect our booster panel to get a lot of overuse. I love covered switches and was delighted to learn that the Apollo spacecraft used them to control various pyrotechnic deployments and separations. Though the cryogenics panel is mostly just a sound and light show, I also programmed in a widely known mishap.
Please stir the cryo pigs.
Houston, we've had a problem. We've had a main beam bus unable.
When playtime is over, the console is shut down with the abort panel.
Mission aborted. Powering down.
The thing that our mission control console is most missing is a spacecraft to monitor and control. Don't worry though, I have plans for that as well.